Find the angle of failure, alpha. In this problem, soil data from a triaxial shear test has been provided, including the confining stress and the axial stress. The failure angle, alpha, is the angle made between the failure plane and the plane normal to the cylinder's axis. Next, we'll sketch out the axial stress and confining stress values and connect them with a Mohr's circle. Next, the cohesion value of 50 kilopascals is plotted on the vertical axis, and the rupture line is traced. Now we identify the point of tangency and the center of the circle. Draw a chord between these 2 points and define 2 times alpha as the angle between this chord and the horizontal axis. The remainder of this problem is simply an exercise in trigonometry. 2 times alpha is equal to the supplement angle of beta 1 plus beta 2. Both beta 1 and beta 2 are part of right triangles, which will be helpful later. A variable x is defined as the distance from the origin to the center of the semicircle, and a variable r is defined as the radius of the circle. Where x is half the sum of the major and minor principal stress values, and r is half the difference of the major and minor principal stress values. Substituting in our stress values, we find that x equals 300 kilopascals and r equals 150 kilopascals. As was given, we know the cohesion is 50 kilopascals. Since the smaller right triangle has side lengths of c and x, we know the length of the hypotenuse is the square root of x squared plus c squared. That way, beta 1 can be defined as the arc cosine of the quantity r divided by the square root of x squared plus c squared. The values are plugged in, and we find beta 1 equals 60.45 degrees. From the diagram, we notice beta 2 is equal to the arc tangent of c divided by x. C and x are plugged in, and beta 2 equals 9.46 degrees. To solve for our angle of failure, alpha, we plug in beta 1 and beta 2, and alpha equals 55.05 degrees. Looking back at our possible solutions, the answer is D.